Hello, this is question 9 on your mix exercise 7 from the Applied Maths book from year 1. A single observation x is to be taken from a binomial distribution B30p. This observation is used to test H0p equals 0.35 against H1 p different than 0.31 is a two-tailed test. Using 5% of level of significance, find the critical region for this test and the probability, be careful because instead of being smaller, should be as close as possible to 2.5%. If they don't say this, it will be just smaller, yeah? So we have two tails and we have that the probability of x being smaller or equal than a, we have to find this a must be as close as possible as to 2.025, and the other half of the critical region is greater than, so this must be as close as possible to 0.025. If they don't say that, both of them are going to be smaller than, yeah? How do we do that? We can use the tables because this binomial, so if this is true, x is going to be a binomial 0.35, and I think this is in the table. 0.35, yeah, is this column here. 0.35, let me clean it. So we look for the first value, for the closest value to 0.025. So we are going to pick one value below, and no, this is not below. One value below and one value above, and subtract from 0.025 to see which one is closer. And you can see that this one is closer, the 5. So A is going to be 5. This means this is going to be 5. So part of the critical region is going to be x smaller or equal than 5. For the other tail, this is not in the calculator, so we have to rewrite as 1 minus probability of x being smaller than 1 less. Like when we have numbers, yeah? This as close as possible to 0.025, which means just rearranging, this probability must be as close as possible to 1 minus 0.05, which is 0.975. We go to the table and look for the closest to 0.975. So one below, no, again, this is not below, this one and this one. And the closest is going to be 15. Yeah, this one is closer. Just subtracting from 0.975. So that means this is 15, which means B is 16. So my other half of the critical region is x greater or equal than 16. Yeah, that's my critical region, is, or I can write this way, or x greater or equal than 16. Yeah, that's the critical region. That's what they asked me in this part of the question. B, state the actual significant level of this test. Remember, that's the probability of falling in the critical region. So that probability is really probability of x being smaller or equal than 5, or, so plus probability of x being greater or equal than 16. This is going to be, we can use the calculator or the table, but as we have the table, smaller or equal than 1 less, yeah? We have the table with the numbers, very easy to find. So this probability of x smaller or equal than 5 is this value here, 0.0233. 0.0233 plus 1 minus this probability, 0.9699. 9699. And this is 0.0534. Yeah, and this is the actual significant level or level of significance. Usually we give it in percentage, so I will write it in percentage. Yeah. And then the actual value of x obtained is 4. State a conclusion that can be drawn based on this value, giving a reason for your answer. So x is 4. 4 is smaller than 5, smaller or equal than 5. So it falls in the critical region. So 4 is in the critical region. Therefore, we have to reject H0, and when we reject, we accept the alternative. That's why it's called alternative, yeah? So we have to accept H1. And we should write a line. I don't have much space, I'm going to write here. There is enough evidence to support, and now we read a bit the question to decide what we say. That the probability is different than 0.35. They don't say much about that, yeah? To support that the probability, to support H1, really, that P is different than 0.35, yeah? Which is H1. And that's all with this question.